Welcome. Today is part 10 of the chapter trigonometric functions, compound angle, multiple angle, and submultiple angle for preparation of JEE Main, Advanced, and for different state level joint entrance examination. First problem for this video is problem number 45, and the problem is the minimum value of 5 cos x plus root 2 sine of x plus pi by 4. Options: minus root 27, minus root 37, minus root 29, and minus 1. So actually we have to find the minimum value of that. If it is of the type a cos x plus b sin x, then its minimum value is minus root over a square plus b square. Because it is linear combination of sin x and cos x, and a and b are coefficients of cos x and sin x. By putting a is equal to r sin alpha and b is equal to r cos alpha, we get that this will be a minimum value of that, and plus of root over this will be maximum value of that. I discussed it so many times in last videos. This one is not exactly to that form. It is actually equal to 5 cos of x plus root 2 into sin x cos 45 degree plus cos x into sin 45 degree. Sin 45 degree or cos 45 degree all are 1 by root 2. So this will be cancelled with that, this will be cancelled with that, so that it is equal to 5 cos x plus this is sin x. This one is 1 by root 2 cancelled, cos x is equal to 6 cos x plus sin x. Now it is of the type this. So its minimum value is minus root over of a squared, that is 36, plus b squared, that is 1. So root minus root 37 is our answer. So option B is correct. Our next problem is problem number 46. And the problem is, if alpha beta are roots of a cos theta plus b sin theta is equal to c, then value of sine of alpha plus beta. Options: 2ab by a square minus b square, 2ab by a square plus b square, 2ac by a square minus b square 2ac by a square plus b square. Now this is a trigonometric equation. Its roots are given as alpha and beta are two roots. Then to find the value of sine of alpha plus beta, and because alpha is a root of that, we must have a cos alpha plus b sine alpha is equal to c. B beta is another root, so a cos beta plus b sine beta is equal to c. From these, subtracting, we must have a into cos alpha plus cos alpha minus cos beta plus b into sin alpha minus sin beta, that is in right hand side b into sin beta minus sin alpha. That side is 0 and this minus that is taken into that side. Now using the formula cos c minus cos d, this is equal to 2a into sine alpha plus beta by 2 into sine beta minus alpha by 2 is equal to 2b into of the type sin c minus sin d. So it is 2, that 2, b is there, sine of beta minus alpha by 2 into cos of alpha plus beta by 2. 2 cancels, sine beta minus alpha cancels. So this by that is 10 alpha plus beta by 2 is equal to b by a. B by a. Now we have to find the value of sine alpha plus beta, and we get the value of 10 of alpha plus beta by 2. We know that sine 2 theta is equal to 2 tan theta by 1 plus tan square theta. Standard formula. Now this is, take this as theta. So sine of 2 theta, that is alpha plus beta, is equal to 2 tan of that by 1 plus tan square alpha plus beta by 2. So this is equal to 2 tan alpha plus beta by 2 is b by a by 1 plus b square by a square. It is equal to 2ab by a square plus b square. So this is the value of sine alpha plus beta, that is required option is this, option C, sorry, option B. Next, next is problem number 47. the numerical value of 3 into sin x minus cos x whole to the power 4 plus 6 into sin x plus cos x whole to the power 2 plus 4 sin to the power 6x plus cos to the power 6x is how much? Numerical value of that. Options 10, 13, 11 and 8. Now an expression involving sin x and cos x with some power is given here. So we have to find its numerical value. For that purpose, let us simplify like that. Take its whole square, then to the power 2. 3 into sin square x plus cos square x, that is 1, minus 2 sin x cos x whole to the power 2. Whole square is this, sin square plus cos square is 1, minus 2 sin x cos x whole to the power 2, power is 4, plus 6 into sin square plus cos square is 1 plus 2 sin x cos x plus 4 into it is sin square x plus cos square x whole cube, a cube plus b cube. There is to the power 6, cos to the power 6 is there. So these two product terms we have to subtract, minus 3 sin square x, a cube plus b cube, 3ab cos square x into sin square x plus cos square x. So that it is equal to 3 into 1 plus 4 sin square x cos square x minus 4 sin x cos x plus 6 into 1 plus 2 sin x cos x plus 4. This is 1 cube, that is 1, minus 3 sin square x cos square x into 1. First we collect the numerical values, 3 plus 6 plus 4. Result. Next, this is minus 12 sin x cos x. This is plus 12 sin x cos x. They cancel. And 12 sin square x cos square x. This is minus 12 sin square x cos square x. They cancel. So all terms involving sin x cos x cancelled. So answer is this. So which is 13. So this option is correct. That is option B is correct. Next problem, problem number 48. The problem is if 0 less than alpha 1 comma alpha 2 up to alpha n less than pi by 2 and cot alpha 1 into cot, not cos, cot alpha 2 up to cot alpha n is equal to 1, then find maximum value of cos alpha 1 into cos alpha 2 up to cos alpha n. Options: half 1 by 2 to the power n, 1 by 2 to the power n minus 1, 1 by 2 to the power n by 2. N angles are given alpha 1, alpha 2 up to alpha n, and they all lies between 0 to pi by 2, that is in first quadrant. And given that cot alpha 1 into cot alpha 2 up to cot alpha n is equal to 1. In that case, we have to find maximum value of that. Option is this. So we have to find maximum value of that in between these. Given that this is 1, that means we must have cos alpha 1. It is cos by sine, So cos alpha 2 up to cos of alpha n is equal to sine alpha 1, alpha 2, sine alpha n. Now, this you multiply throughout by cos alpha 1, cos alpha 2 up to cos alpha n. So that this is equal to cos alpha 1 into cos alpha 2 up to cos of alpha n whole square is equal to sine alpha 1 into cos alpha 1. I have taken cos alpha 1, cos alpha 2, cos alpha n. I multiply this on both sides. Here I adjust only cos alpha 1. Then sine alpha 2 into cos alpha 2 up to sine alpha n cos alpha n. Now it is adjusted whole square. Now if you multiply 2 here, 2 there and 2 there, that is 1, 2 up to n factors. So 1 by 2 to the power n. This become 1 by 2 to the power n into sine 2 alpha 1 into sine 2 alpha 2 up to sine 2 alpha n. Now, as because alpha 1, alpha 2, alpha n all lies in first quadrant, the 2 alpha 1, 2 alpha 2, 2 alpha n must lie between 0 and pi. That is, sign there is positive and they are all positive, and its maximum value is 1, its maximum value is 1, and so on. So that it is greater, less than or equal to 1 by 2 to the power n into 1 into 1 into up to 1. So it is actually less than or equal to 1 upon 2 to the power n. So this whole square, its maximum value is that. Therefore, maximum value of cos alpha 1 into cos alpha 2 up to cos alpha n is less than or equal to 1 upon 2 to the power n by 2. So its maximum value is 1 by 2 to the power n by 2. That means this is correct answer, option D. Next, now problem number 49. Problem number 49 is, if 0 is less than alpha less than beta less than pi by 2, that is alpha and beta both lies in first quadrant, and cos x is equal to cos A minus cos B by 1 minus cos A cos B. Then value of tan x by 2, how much? And options are tan A by 2, tan B by 2, tan A by 2, cot A by 2, then tan A by 2 cot B, and last one is option is tan A by 2 cot B by 2. Base. Two things are given. Number one, the angles alpha and beta, they lie in first quadrant, and there is a relation between x and AB. Cos x is equal to that. Then to find this, so cos x in terms of cos x by 2, you see cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. Using this formula, this become 1 minus tan square x by 2 by 1 plus tan square x by 2. 1 minus tan square by 1 plus tan square is equal to this intact, cos A minus cos B by 1 minus cos A cos B. To find, we have to find tan x by 2. So from there, by computando and dividendo, we can obtain value of tan square x by 2. So by computando dividendo on both sides, it is equal to 2 by this plus that cancels, 2 by this cancels, 2 tan square x by 2 is equal to. Now actually we have added there this, so it is equal to cos A minus cos B plus 1 minus cos A cos B by, and in that case this minus that, so 1 minus cos A into cos B minus cos A plus cos B. From there 2 cancels 1 upon that. Here let us try to factorize it. Taking common cos A, it is 1 minus cos B, this with that, plus 1 minus cos B. In denominator, they together is 1 minus cos A, and they together, taking cos B common, 1 minus cos A. So that it is equal to 1 minus cos B into 1 plus cos A by, here 1 minus cos A into 1 plus cos B. Now this by that, 1 minus cos A by 1 plus cos A, it is equal to tan square, uh, just 1 minute, 1 minus cos 2 theta by 1 plus cos 2 theta of that type. So it is equal to 2 sine square theta by 2 cos square theta. So 2 cancels, tan square theta. So in that case, this by that it is equal to tan square A by 2, and this by that, this is equal to tan square B by 2. So that tan square x by 2, it is in denominator, it is equal to tan square A by 2 in denominator, and this is in numerator, it would be cot square B by 2. So tan x by 2 is equal to plus minus tan A by 2 into tan cot B by 2. But as because both A, A and B are in first quadrant, so we have to take the positive values. So tan x by 2 is equal to tan A by 2 into cot of B by 2. So option D is correct. Okay. Today is up to this. I request you to please subscribe my channel and share it to your friends so that they can use it. Thank you.